Hello and welcome to this new Sustainability Lunchtalk, the first of the new season. Can you hear me? It's okay? Yes, great. A lot of noise outside. They are cleaning the windows, so I will make it short. As usual, this Lunchtalk is recorded and will be made available on the sustainability webpage the day after this talk tomorrow. Please be aware that we will not take questions during the presentation, as a dedicated Q&A moment will take place at the end. If a question pops up during the talk, feel free to write it in the chat, and we will pass it to the host at the end. My name is Mathieu Gilleron, and I'm project manager in sustainability for the University of Luxembourg. With my colleague Laurent, one of our missions is to raise awareness on sustainability among the community. To help us, we have the chance to be surrounded by brilliant professors, researchers, and staff members. And for this new Sustainability Lunchtalk, and the first one of the season, we wanted to highlight the subject of logistics. As I mentioned in my invitation, in 2020, a turning point was reached. According to an article in Nature, the global mass of human-made materials exceeded all living biomass on Earth. On average, each person now produces more than their own body weight every week. This level of production and consumption would not be possible without the support of modern logistics. For instance, container ship traffic alone increased 20-fold between 1980 and 2017. In response to growing concerns about sustainability, many businesses are advocating for sustainable logistics, which includes adopting electric vehicle fleets, optimizing transportation routes, and relocating production closer to demand. However, the impact of logistics extends far beyond just environmental concerns. And behind the green promises, there is a risk of falling prey to greenwashing. And that's why we invited Professor Joachim Arts to talk today. He's a professor of operation management and logistics at the Luxembourg Center for Logistic and Supply Chain Management. And the co-host for the day will be Professor Markus Hesse, who is a professor of urban studies at the Department of Geography and Spatial Planning, once again at the University of Luxembourg, and part of the Faculty of Humanities, Education, and Social Science. Markus, the floor is yours now.
Okay, thanks very much for inviting me. That's a really exciting opportunity to bring sustainability development and logistics together. This is not only the case because there's no easy path available in these subjects as concerns desired solutions or strategies. It is particularly because each of these two topics, they have commonalities, and one is they are all-encompassing, they are complex, and they are pretty contradictory. And the latter, contradiction, maybe also political contestation, seems even more pressing when we discuss logistics under the umbrella of sustainable development. So this is really a hot topic. And there are good reasons to do research on it, and we look forward to hearing more about them in a few moments. So these talks usually have a co-host who is invited to give some introductory remarks. And what I'm going to do is just to give you an idea of what these two subjects, what the basic understanding is and how they relate to each other. So I guess everybody knows a proper definition of sustainable development. If you just take the classical one provided by the Brundtland Commission in 1987, sustainable development is seen as a development that meets the needs of the present generation without compromising the needs of future generations. And what was new at that time, which is quite a while ago actually, when it was invented for the very first time, a political focus was put on both the environment and development. It was an integrated approach across nature, society, and the economy that was put forward. and it had an intergenerational perspective, reflecting upon future needs and interests. Well, whatever you know about it. This approach was and still is revolutionary. The associated integrated approach to sustainable development is part of its popularity in the policy realms, but also indicates its dilemmas and limitations. The trilogy of goals is difficult to manage. It faces strong political and economic resistance. And there are many trade-offs between the different dimensions, the environmental, the economic, and the social. Just to name one, you can be pro-competition or pro-environment without considering the social dimension of such policies. Therefore, sustainability should clearly not be confused with green. It may also be important to be aware of the current state of affairs regarding the implementation of sustainable development, as it is measured, for example, by the 17 Sustainable Development Goals formulated in 2015. Last year, the United Nations published an interim report on implementing these SDGs, and the result can actually only be described as sort of depressing. Quoting one of the points made in that report, "We are at war with ourselves and with nature." Across the 17 SDGs, implementation seems further away than before. Additional challenges have emerged in recent times, especially when politics turns populist and powerful forces are up to defending the status quo. So coming to logistics, sustainable development is already a rather complex and contested issue, and the same could easily be said of logistics. The underlying principles of logistics, the supply and delivery of materials, components, and products in the most efficient, timely, and cost-effective manner, have become standard business practice. Over decades, logistics has evolved from a cost-cutting device to an emerging system of supply or provision. And this system is structural. For example, it is ubiquitous in retail and wholesale, and it even fills your fridge. At the same time, it is considered a separate sector of the economy that runs shipping containers, terminals, truck fleets, or warehouses. Logistics appears as a tool that can be used and has been used in the past for many different purposes. It has emerged as one of the three sciences of warfare, along with strategy and tactics. It has contributed to major transformations such as industrialization, enabling the concentration of raw materials, capital, and labor in selected places. It has been and continues to be an important means of resource extraction, as it was once key to colonialism. In today's context, logistics has simply enabled globalization. Without it, the subsystems of goods production, trade, and consumption could never have been integrated. And if the world economy were one day to be reorganized along more regional or circular patterns of value creation, logistics organization and technology would certainly have to assist as well. So coming to my short conclusions, how about sustainable logistics? This is today's subject. And before handing over to our speaker, how do these two issues relate to each other? Where do they conflict? I may just for time reasons pick three points. Today's topic is highly relevant, first because of resource consumption associated with logistics. Moving things necessarily relies quite heavily on the use of fossil fuels. The growth of the industry, second, has had a massive impact and footprint on the built environment through the expansion of airports and port areas, or by urbanizing the city's hinterlands. This, incidentally, has also attracted the interest of geographers and spatial planners like myself. Third point, logistics is also the subject of social science research, for example, when the working conditions of seafarers or truck drivers are discussed. Finally, in all sustainability contexts, as it is a political program, the governance dimension is hugely important. Decisions are usually made at different ends of the supply chain, and not always where we have certain problems. Power is unevenly distributed and sometimes concentrated at multinational firms. So the big question is actually, if we discuss logistics under the umbrella of sustainable development, who is in charge of change if we accept the notion that change is necessary? And how far will we get in not just greening the business, but making it truly sustainable? I'm very lucky that I can stop here because I don't have answers to these big questions, but I enjoy the privilege to hand over to our colleague, Joachim Arts. Thank you.
So the bad news is I don't have all the answers to these questions either. The good news is I do know a couple of places to start, right? And that's, I guess, the best we can do, rather than trying to find one way to solve the whole problem in one go, which I don't know how to do, and I think very few people will know how to do, is take a specific problem within this domain and try to solve it. And so my plan today is to show you what I'll call 3 vignettes of problems that there's research at the University of Luxembourg that explains how to tackle some of them. And you can see on the top of the slides basically the 3 specific problems that I want to look into. And you will notice that 2 of them are mostly about, let's say, green. And like Professor Hesse just said, green is sustainability is not just green, but it is, of course, part of sustainability. And the last vignette is about ethical sourcing. It's more about the social dimension of sustainability. And I'm going to start with last mile emissions. Now, when you look at a typical supply chain, and you see here on the left a supply chain of solar panels, the amount of goods and components that are moved around the world and somehow assembled before it gets the solar panel on somebody's roof somewhere is really quite staggering. It is so large that it's one of those systems where you think, well, if I want to get a hold of it, where do I even start? And so traditionally, supply chains, there's people who focus mostly on transportation, there's people who focus on running certain production plants. And in any case, any decision that you make anywhere in the supply chain can affect everything going down, right? And it is a very complex system to deal with. And so what we do is we try to cut it up in sizable chunks that we can have something reasonable to say about. And the first such chunk is last mile emissions. And I'm going to give some credit to my collaborators all over the world because I don't want you to think that I am coming up with all of this. This is the joint work of Moulin, who's a PhD student at the LCL, and Jose Velasquez, who is a research scientist at the MIT Center for Transportation and Logistics. And it's about last mile emissions. So at the very end of the supply chain, there's the last mile that a good goes through before it actually gets to your porch or before it gets to the store where you do your shop. And for this, there's a lot of routing trucks that you see driving around in the city that happens. And a lot of these trucks, what they do is they try to find the route that is the shortest. Now, what you see here before you are 2 examples. In the example on top, you see the truck that needs to drive uphill for a distance of 3 kilometers. I don't know if you can see my cursor. At a very steep angle of 3 degrees. And then it drives downhill for a distance of 12 kilometers over a relatively shallow bank, which means that in total, the truck will drive 15 kilometers. In the scenario below, from the same point A to the same point B, there's another route that goes uphill for 10 kilometers at a very shallow angle, and then downhill for 2.5 kilometers at a much steeper angle. And the question is, which one of these 2 routes either emits fewer carbons if you're using a combustion engine, or which one of these uses less of your battery power if you're using an electrical vehicle. And common wisdom is to say, well, whichever one is the longest route is probably one that emits the most, but it turns out that that is not true. And the reason it is not true is that even though path 1 is 20% longer, which seems a lot, the path 1 has an emission reduction of about 14% relative to path 2. And the reason is if you go uphill and go downhill for a long time, you can basically, if you ever drive downhill, you don't have to touch the gas pedal very hard at all, right? If you go uphill, you have to kick it in a bit more all the time. And so the amount of fuel that you actually burn, and therefore the amount of CO2 that you emit, is shorter when you take into account how elevation changes over your route. Which means that if you want to do efficient last mile logistics, you don't only look at distances. What you should be looking at is the elevation, not just at your beginning of your end point, but every fork in the road that you cross as you go from A to B. And so in order, if you want to do routing in a green manner, you need a physical engineering model of how your combustion or your electrical engine actually works. You need to optimize your speed because the amount of carbon that you emit also depends on the speed that you drive at, because engines have different working efficiencies at different speeds. And you need a detailed map that tells you, well, everything that's going on, but also the elevation of every point and every fork in the road. And then in this research, we obtained this data from the US Geological Survey, which gives you very granular data of elevation all over the world. Now, if you do this, let me show you a couple of examples. This is in Luxembourg. You're going from Limburgsberg over here, where one of our campuses is, and you go up to Bergen over here. And the red line that you see is in fact the shortest route, and the green line that you see is in fact the greenest route. That's why I colored it green. Obviously, the green one is longer. So why is it greener? Well, what you can do is you can take a look where you put here, and I put it in the figure here, where you put the distance that you've already driven on the x-axis and your elevation, in this case above sea level, on the y-axis. And what you see when you take the shortest path is it goes up and down a couple of times. Whereas the greenest path, which is either the orange or the green one, they are the same in this particular case. It goes downhill and it tries to avoid ever going back uphill again, such that you have, well, the wind in the back or the downhill feeling all the way there. And you see it when you look at the CO2 emissions. You look at the amount of CO2 emitted as you drive along the route, and it grows very steeply a couple of times if you go up and down. But if you keep going downhill, it doesn't grow nearly as steeply, and you can have a 30 to 37% reduction in your CO2 emissions. This is another case. This is Merle, right, on the west side of Luxembourg. And over here is Strassen. So you're going from Merle to Strassen. And there are two routes. One of them, the red one again, the shorter. The other one, the more carbon efficient route. And what you avoid is going way uphill and way downhill. And it saves you, in this case, 45 to 46% in carbon emissions. Well, you look at these examples and you will say, well, Joachim, that's nice, but I'm guessing you really doctored these examples because these numbers are really excessive. And of course that is true because I'm showing the examples to illustrate the point. But if you take many, many origin-destination pairs in Luxembourg, for example, and we did this for many other cities, but in this example it's in Luxembourg, you can look at how much you can emissions you can save if you're driving either a heavy-duty truck, a medium-duty truck, or a lightweight truck from left to right. And what you see is that the mean saving across the board is around 5%. So if you go and use elevation data to make sure you don't have to press your gas metal, you can really reduce emissions on average by 5%, and in some extreme cases up to 50% or more. Okay, that's one vignette. The other vignette is when you really look at global networks of production and transportation. This is joint work with Matteo Cosmi, who's a postdoctoral researcher at the Center for Logistics and Supply Chain, and Stefan Prosterhalfen. I won't tell you his affiliation, but you can look him up and then you can make an educated guess of the company case that I am about to talk to. So, when you look at a supply chain, and in this case I'm looking at the chemical supply chain. So the chemicals go into almost every product that you have eventually. So chemical supply chains are upstream of almost any supply chain that you see in the world. And what you see here is a very small, very simple supply chain to illustrate. There's a number of places where you mine goods, right, which might be drilling oil, that might be getting ore from a mine. And then it goes through several production steps and transportation steps before it eventually makes its way to global markets, where these are used by, I don't know, the plastic in your mobile phone or whatever. You can optimize such a supply chain, and usually when we optimize such a supply chain, we look at the profitability. In technical terms, we look at the contribution margin. Contribution margin is basically the revenue that you can create minus the costs that are due to your supply chain operations. If you do that, that is great, but now most decision makers have more objectives than just making a large profit. Many have now set themselves goals to reduce the carbon emissions of their supply chains, but at the same time, they are still in the money-making business. So the question is, if I want to reduce my CO2 emission, how much do I actually lose in the contribution margin? How much does the supply chain lose in profitability? And we did that for a real case. And what you see here in the graph on the right is that you can reduce CO2 emissions by 5% without almost any impact whatsoever on the profitability. Profitability goes down by less than 0.5%. When you show graphs like these to decision makers, all of a sudden there's a strong incentive to at least reduce CO2 emissions by 5% and maybe make investments to do it even more. And the question is, how do you actually reduce your CO2 emission without hurting your profitability? And then for the supply chain, I'm going to look in what activities in the supply chain actually emit. And in the gray, you see the use of utilities. So electricity, gas for heating and other processes. There's transportation of goods between sites. There's raw materials procurement, because if you buy a material, that material has already had a supply chain ahead of it, and all of the carbon accounts in that is in there. And then there's the manufacturing operations of the supply chain itself. One of the things that you see here is that actually transportation is not one of the most important sources of emissions in global supply chains. One of the most important sources of emissions is manufacturing and all of the utilities that are used in that manufacturing. And what you see here is that, what you see is that transportation emissions actually go slightly up, but utilities emissions go drastically down, right? The gray band goes drastically down. So what you do is you transport a bit more and you use utilities a bit less. And the way you use utilities a bit less, and I'm going to show you a picture here of how the emissions are distributed by different continents of the globe, because this is a global supply chain. APAC stands for Asia Pacific, EMEA for Europe, Middle East and Africa, Latin for Latin America, and NA for North America. What you see is that Europe, the red band, is initially less wide than it is towards the end when you have a large CO2 reduction. And the emissions in China is initially wide and is very narrow at the end. And the reason this happens is that the most polluting manufacturing sites right now are very often located in Asia Pacific. And so if you want to reduce your global supply chain, what you need to do is you need to move production from, let's say, the gray plants in Asia Pacific to greener production plants in Europe. And so in order to reduce your global supply chain, you move production back to Europe. The result is that your carbon footprint in Europe actually goes up, but your global supply carbon footprint goes down, which is a paradox. And it's a problem because decision makers like governments, you know, the EU can only talk about European emissions. They want to bring European emissions down, but maybe the most effective way to bring emissions down is to take a global perspective. And that's what you see here. Okay. Last vignette. Ethical sourcing. And this is work that was started by Hanit Sina. He's a PhD candidate at the Center for Logistics and Supply Chain Management. He has a number of other co-authors, which is a longer list. And he used to work in the garment industry before he became a PhD student. And as such, he has a good understanding of how this industry works. And, well, you might know that the garment industry is one of the industries where modern slavery is really an issue. This is an article that Hanit also sent to me a few days back. It's from 17th September, so this was just 2 weeks ago, roughly. And it was about modern slavery in Leicester, in the United Kingdom, where there were shops where people would put together clothes, working for £3 an hour, which is far below minimum wage in the UK. All right, so this is something that happens in different places. Now, if you are a brand that sells garments, and you want to make sure that there is no modern slavery in all of the places where you procure or source your garments. How do you do that? Because typically you have a large base of suppliers, and it's almost impossible to check all of them. They are in different parts of the world. How do you go about that? And this is a difficult problem. You might remember about a decade ago, we had this scandal where there was horse meat in the beef in several places. And this was already hard to track down, and this was for a supply chain that happened entirely in Europe. And it was also easy because if I give you a pack of meat, you can run it through a DNA analyzer to see if is there horse DNA in there or not. Right? But if I give you a shirt, you cannot possibly know whether this shirt at one point in time was touched by slave labor or not. So how do you assess the risk and how do you find it? Okay, so what you see here on the right is what one of those sweatshops, as we call them, looks like, right? Where slave labor produces these garments. Hanit was very familiar with the industry in Vietnam. So what he had is he had data from several sources, the Vietnam Enterprise Survey, so it's statistics gathered by the government, bill of landing of export data, right? So whenever you export goods and go to get somewhere, there's a bill of landing that is kept. Within the industry of garments, there's general sewing data about how long does it take an average seamstress or a seamster to put together a t-shirt or a coat or whatever. And then you have field study data where they actually visited a number of these factories and looked at the output as a function of the amount of capital investment, the location where it is, and a number of possible confounding factors. And then you ask yourself a very basic question. How much did the firm actually export? You can get this from the bill of landing data. And most of these firms do only export. They don't produce for the domestic market. So you look how much did a firm actually export, and how much can a firm be expected to produce given the labor and the capital and the other production means that they have that are officially reported and are audited by the government. And when you set these two against each other, which you see here, where you see on the y-axis how much they actually exported, And on the x-axis, based on all the data that you have, how much you can reasonably expect them to produce. And what you see here on the top left are companies that export significantly more than the labor that they officially report and the production needs that they can can actually quantify. And the interesting thing is that this graph was created without visiting any factory. These are all statistics that in principle you can buy or you can collect yourself without the permission of the companies themselves. And what you see here is these companies, there is something fishy going. Now, of course, you don't know for a fact that they're slave labor, but if you're going to audit your suppliers, I know which suppliers I'm going to audit first, and I know that I'm going to do it quite deeply when I look at these suppliers. And it's a way to find out what's going on and what can you do about it. Okay, that's about the 20 minutes I have prepared. So these are 3 vignettes of specific problems that you can pick up and start working on. And it's an illustration of all the good work that I think is being done at the University of Luxembourg in this domain. I'll finish now so we have time for discussion and questions.
Thanks very much, Joachim, for this very insightful talk about logistics issues with respect to sustainability. And it's pretty clear where challenges are also in not only in policy terms, but even in getting a grip of this whole problem. And I guess we can also see the trade-offs, the difficulties to decide what sort of problems should be addressed first and how do we deal with others. So that's really interesting. We have already a question on the chat. So once again, everybody is invited to leave comments or questions over the chat. Even though this is called a lunch talk, we do not talk, but we do this mediated through the machine. Niels Rehlinger had addressed the question, Google Maps also gives suggestions for green paths. Do they also take elevation in mind, is the concrete question. Joachim.
Google is closed source, so we don't actually know what Google does. In fact, while we were doing this research, we were about in the process of finishing this research when Google started doing this. So we don't know what Google does. I think they probably do, but I can't say for sure. What we can do, of course, is we can compute the greenest paths ourselves and look at what Google does, and very often they are very close. So they are probably doing something of the sort, but it's not always quite the same. And we don't know whether it's because our algorithm is slightly different or our data sources are slightly different. I don't know if that is an adequate answer to you, but I think yes. The point is that you use Google, probably, which is great. But the big trucking companies, they use different routing software. So the next step is for either these big routing companies to verify that Google actually does this and use Google, or to incorporate this knowledge in different types of routers that are used by different companies.
So there is a longer information which by Alex Skinner, which I guess is not necessarily a question, but a hint on Google Maps calculation of fuel and energy efficiency. Alex is a colleague here from the geography department. We estimate energy and fuel efficiency based on insights from the US Department of Energy's National Renewable Energy Laboratory and data from the European Environment Agency. This calculation includes factors that affect your fuel and energy usage and carbon dioxide emissions, like average fuel or energy consumption for vehicles in your region, the steepness of hills on your road, stop and go traffic patterns, types of roads such as local roads or highways. Maps, I guess he talks about Google Maps recommends the most fuel or energy efficient route when it has roughly the same arrival time as the fastest route. In cases where fuel or energy savings are too small or driving time increases significantly, Maps shows relative fuel or energy savings between routes to help you compare. So this is not only big data if you want, but it's also a tool where you can make some comparisons and optimize your decisions on it. Would you like to add to that, Joachim? Thank you, Alex.
I think Alex gives an excellent summary. In fact, we also have a number of approaches that we compare. One of them is also about, well, how do you optimize your speed along the route? For the interest of this talk, to illustrate the point, I didn't go into all of the details of how you do this. There's many things that you look into, including, like he says, traffic, right? Because the route can be very fuel efficient, but not if you get stuck in traffic. If you include things like traffic data, elevation sometimes becomes even more important, is what we notice. I guess the main message is that the idea that you should go the shortest or the fastest, we need to get away from that. We need to think about what is actually efficient. And elevation data is key to make that happen. And there's different ways to make that trade-off against other considerations that you might have when going from A to B. And I guess Google is also a way.
Okay, thank you. There are two more questions. Again, Niels Rehlinger, seeing as production emissions often exceed transport emissions, are imported fruits, vegetables generally more sustainable than local meat productions?
That's a good question. So look, if you want to grow an avocado here, you need to put it in a place that mimics the climate that crop needs to grow. And if you're going to do that here, what you're going to do is you're going to use a lot of gas to heat the place and things like that. So an avocado grown here versus an avocado grown in a climate where it naturally arises and then transported here, probably the avocado grown in the natural climate and brought here, it has a lower carbon footprint. Of course, the other thing that you can say is, well, if you want to be really sustainable, what you need to do is you need to eat crops that grow locally where you live. That is really the best thing that you can do if you're talking about fresh produce. Unfortunately, I also really like avocados, so every now and again I also do eat avocados.
Thank you. There's another question by our colleague Pierre Picard, and who asks, in the truck emission model, it would be nice to include the value of time, labor, capital, and carbon emissions, given that there is a certain price for emitting carbon dioxide. Any thoughts on that? Is that already foreseen or even practiced?
This is actually something that you can do, right? So what you can do is, instead of looking, you can look at the shortest path, which is what algorithms typically do because it's the easiest thing to do and you easily have the data. You can look at the greenest path, and you can look at the most cost economical path, including, let's say, the cost of emissions, which is then, which used to be an externality, and you make it internal once you have a market where you trade emission rights. In principle, you can do this. It just makes setting up the model slightly more complicated, because if you do this, you need to account for the time of the driver, you need to account for the emissions that you emit, you need to account for a number of things. And one of the other things that you need to account for in practical settings is that you need to still arrive. If you tell your customer I will be there between 2:30 and 3, they don't like it when you show up at 1 or at 4. Right? In principle, you can include all of these things. You just get a bigger model if you do. The question is, what are the most dominant effects? Usually what we have found is that the effect of the carbon emission on the actual travel time is usually not large enough for people to worry about. So in principle, you can do it very thoroughly. The setup of doing it practically is quite high. And so what you try to do is figure out what is really the most important things that you should incorporate and where can you cut corners, let's say, in a practical setting.
Thank you. There's nothing left in the chat so far, so I allow myself to add one more question as concerns this vignette number 3, which I found really striking about ethical sourcing, and not only in terms of generating these data without being on site, but I was wondering, there is a big debate, has been a big debate, and also legislation in Europe, in Germany, for example, about supply chain regulation in order to address issues such as unethical sourcing and modern slavery. Is this sort of research that you are supervising, is that also something that gets at some point in conversation with policymakers, either to offer some analytical tools and knowledge, or maybe also to discuss what could be done? We know that this legislation is quite unpopular in corporate corners. So there's a lot of reporting duties associated with that, which companies don't like. So the question is, how can this whole awareness for unethical sourcing and slavery exploitation issues, how can that be improved? And could logistics research play a role in that?
The research that I just talked about really takes the perspective of the firm, not the policymaker, right? So we're saying you have a firm, you, for whatever reason, either because you are a strong believer that you want to avoid modern slavery, or because you are forced by a policymaker like government, you need to find out, well, I can't possibly audit all of my 100 suppliers thoroughly. Which ones are the ones that I should go first and do thoroughly? That's really what the research answers. We haven't interacted directly with policymakers. What I guess will happen is, as we create tools that make it easier to identify the risk of modern slavery and other social practices that are problematic, if you make it easier for companies to do this, policymakers at some point will find out and say, well, if it's not too hard to do it, then you should do it. Right? So there are two things happen. Policymakers says it needs to happen. We develop tools. If the tools develop well and are easy to use, then the policymakers will say, well, if it's not that hard to do, then everybody should be doing it. The making the tool easy enough for everybody to do it, that is really hard, because it's really a question of what data can you make available at different settings. And in this case, Ramit, because he knows this industry well and actually spent time on the ground in these spaces, he understands what data is available and how you can combine it. This is not easy to do in general, because if you ask me the same question about, I don't know, small metal parts that go into an engine that are made in a job shop somewhere, what are the data sources to look into? That becomes a more difficult question, at least to me, because I'm not intimately familiar with that industry. But for each industry, you need people who know it, that take an interest, and try to combine these data sources to really make it easier to identify where the risk is. And then policymakers will either force you to do it, or if you do it, will make it mandatory for everybody to do it. It's what I think and what my hope is, I guess.
Thank you. There's another question by Pierre Picard. He asked, could it be relevant to include emissions in a spatial economic model where the locations of firms and workers are endogenous? For example, could emissions be included in worker commutes?
Yes, it's a good question. I guess this also relates as much to your field as it does to mine, Professor Hesse. So if you want to comment on this one, feel free. Look, cities grew historically, usually, near waters. If you were to redesign from scratch, you would design in such a way that you don't need to move goods a long distance at all. So if you make it endogenous, yes, there's a lot you can do. Practically, it's really difficult to move people from where they are right now, which I guess would be the main challenge. If you find, well, people should live in different parts of the world, and production should be moved to different parts of the world. In principle, you could create such a model to actually make people then behave accordingly, I think is really the challenge.
Thank you. Are there any further questions, points of interest?
I guess people have more time for the coffee machine before they get back to work.
Yeah, thanks to logistics provision. Mathieu, would you like to take over?
Thank you very much, Markus. Thank you very much, Joachim, for this this interesting talk. Once again, everything will be online, so I know a lot of people couldn't attend today, so you can share with them the link. Thank you both for doing this. Thank you both for taking the time to discuss this subject. We hope you all enjoyed it. Before closing this WebEx and leaving you to the rest of your day, I would like to kindly invite you to our next Sustainability Lunchtalk. It will be on December 11, and it will be about repair as a design paradigm. It will be with Dr. Maria Maric from the Faculty of Humanity, and it's also a very interesting subject, so we're really looking forward to this next lunch talk. You can find the program for the future lunch talk on the website of the university on the sustainability page. We have a very, very nice program for this year again, and thank you again. Have a nice day.
Thank you.